Hello grade 12, I hope you're doing good and you're safe with your families. This is chapter 3 of the book as we need to move on. Bonding. So probably you know that the aim or goal of making a chemical bond for an atom is to become chemically stable. This is why noble gases, which are already stable, do not make chemical bonds. They have 8 valence electrons, which are the valence electrons on the S and P sublevels. So this is the Octet Rule, except for hydrogen that has 2 valence electrons, or what we call the Duet Rule. The first type of bond is the Ionic Bond, where an electron is transferred from one atom, losing an electron, called the cation, to another atom, gaining an electron and called the anion. And here we can see in this representation how one orbital, which had one electron, is now empty, and another orbital is now full, so both are now more stable. In covalent bonds, we do not have gain and loss, but we have sharing electrons. So the two types of covalent bonds are a polar covalent bond and a nonpolar covalent bond. Nonpolar forms between two identical atoms, like two fluorine atoms. Always whenever we have two different atoms, so we have a polar covalent bond. However, the molecule itself can be nonpolar. So these are examples of CO2, CH4, CCCl4, all nonpolar molecules. However, the hydrogen bonds, the covalent bonds are polar. In most cases, what we see is each atom in a covalent bond is putting an electron in common. However, we have cases where both electrons come from the same atom. For example, here in an H4+, these two electrons come from the hydrogen atom. And here in H2SO4, we see that these two electrons between the sulfur and oxygen both are coming from the sulfur. So why do they bond? As we have explained earlier, because they become more stable, and here we can see that at a specific distance between the two atoms, the potential energy is the lowest. So they want the energy to be low. So as the atoms approach each other, the potential energy decreases. However, then at a very close distance, the potential energy increases again. This is why they stay at an optimum position in covalent bonds.